You know that weather forecast on your phone? Ever stop and think how it got so ridiculously accurate? It's this incredible story, really, stretching all the way from old folk rhymes to modern supercomputers. So let's dive in and see how we learn to actually predict the future one day at a time. You've probably heard that one, right? For centuries, this was pretty much the best we could do. These old sayings, passed down for generations. And sure, they were based on watching the sky, but they were basically just random observations. It was definitely more of an art, maybe even a guessing game, than a real science. But then in 1848, things started to change, big time. The Smithsonian Institution, led by a guy named Joseph Henry, had this revolutionary idea. What if we actually collected weather data from all over, systematically? So they gave thermometers and barometers to 150 volunteers, who then telegraphed their readings back every day. This was the actual birth of a national weather network. And once you have all that data pouring into one place, what can you do with it? Well, you can make a map. And this was a total game changer. For the very first time, people could actually see that weather wasn't just a local thing happening over their heads. It was this massive, moving system. This is when weather really became a science for everybody. Okay, so seeing the weather on a map was a huge leap forward. But to really, truly understand how these systems worked, scientists knew they had to go up. The next big frontier was the upper atmosphere, and one place in particular was about to lead the charge. And that place was the Blue Hill Observatory, right here in Massachusetts. Founded way back in 1885, this place became a hotbed of innovation. In 1894, get this, they launched the world's first ever weather kite. They were literally flying instruments high up into the sky to get readings from the atmosphere. Talk about reaching for the clouds to get answers. And if you ever needed proof of why this work was so incredibly important, just look at this number. 186 miles per hour. That's the wind gust their instruments clocked during the monstrous hurricane of 1938. It's still one of the strongest gusts ever directly measured, and it's a terrifying data point that proves that getting accurate observations could be a genuine matter of life and death. So data collection is getting better and better, right? We're measuring things on the ground, in the air, but around this same time, a British mathematician was cooking up an idea that was so ambitious, so far ahead of its time, it sounded like pure science fiction. This guy's name was Lewis Fry Richardson. In 1922, he publishes a book laying out a complete mathematical system for predicting the weather. The thing is, even he knew it was wildly impractical for his time. He literally called it a dream himself. But the blueprint, the core idea, was all there. So without computers, how in the world did he think this could work? Well, he imagined this, something he called a forecast factory. Just picture a colossal hall, like a stadium, filled with 64,000 people. Each person is a human computer, doing one tiny calculation and then passing the result to their neighbor. It was an idea for a human supercomputer, a whole orchestra of arithmetic, just to predict the weather faster than it was actually happening. Just a wild, brilliant image. So Richardson decided to test his equations himself, not with 64,000 people, of course, just with a pen and paper. He tried to calculate a simple 6-hour pressure change over one spot in Europe. The result? It was a complete and utter disaster. He predicted a pressure change of 145 hectopascals, a number so ridiculously large it's almost funny. The wildest gusts would have been closer. So what went wrong? And here's the really fascinating part. His math was actually correct. The problem wasn't the equations, it was the data he started with. See, tiny, unavoidable errors in the measurements created this high-frequency mathematical noise. These spurious waves completely drowned out the real weather signal he was trying to find. It's kind of like trying to hear a whisper in the middle of a rock concert. It's just impossible. So Richardson's dream wasn't wrong. It was just waiting for the right tool. His whole forecast factory of human computers was a fantasy, sure, but the mathematical logic behind it, it was perfectly sound. It would just take a few more decades for technology to finally catch up to his vision. And here it is. Here's that tool, the ENIAC, the first general-purpose electronic computer. In 1950, a team of scientists programmed it with a simplified set of weather equations, and crucially, they filtered them to avoid Richardson's noise problem. And for the first time ever, a machine successfully predicted the weather. The dream was actually becoming a reality. And this comparison just perfectly captures how far we've come. That first forecast on the room-sized ENIAC took a full 24 hours to predict the next 24 hours of weather. Now, fast forward to 2008, a simple Nokia phone, which they called the Phoniac, could run the very same calculation in under a second. That's just the mind-blowing power of exponential growth in computing. But today's forecasting isn't just about raw computing power. It's a massive collaborative effort. I mean, getting that forecast to your phone requires this incredibly complex ecosystem of different players all working together. It's really this symbiotic system. You've got the National Weather Service handling the big public warnings and forecasts. Then you've got private companies that take that data and create specialized forecasts for, say, airlines or farmers. At the same time, universities are pushing the boundaries with new research, and organizations like the American Meteorological Society act as a sort of neutral ground where everyone can come together and move the science forward. So let's just bring this all together for a second. We went from folklore scribbled in an almanac to a network of volunteers with telegrams to a completely fantastical dream of a 64,000-person computer, and from all that, we've built a system that performs a little miracle for us every single day. Richardson himself wrote that the ultimate test of any science is its ability to predict the future. And by that measure, meteorology has become one of our greatest scientific success stories. It proves its value every single time we check the forecast, plan a trick, or get a storm warning on our phones. The forecast in your pocket, something we take for granted, was a dream so wild that its own creator called it a fantasy just a century ago. It really makes you wonder, doesn't it? What seemingly impossible scientific ideas today are just waiting for the right tools to become the mundane reality of tomorrow?